talking to each other.
We're going to get started, everybody. Feel free to get more pizza or drinks during the talk if you want. Okay, so I just want to start off by saying everybody should shut your laptops. This isn't interactive. We're just going to kind of go through a few things, and then at the end we're going to go through a workshop. So if you have a laptop out, just put it away for a moment. And I want to show you where we're going to end up after this talk. So we're going to end up making Pac-Man with JavaScript. So it goes through and it just eats all the little things. You can stop it, start it. So yeah, we're going to learn to do that. And Alex is going to kick it off.
So we're going to start with the basics of like programming JavaScript. I just want to know, who here has like a programming background at all? Okay, that's what I expect. So it's got to start from like, we're going to start from like the basics of basics. So I guess let's start with, what is a program? And I guess it's like, it's more so like instructions telling the computer what exactly to do. And if you think about like a book, the book as a whole is the program, and it's written in a specific language, and the code is basically the words and the lines that make up this book. So one of the base level pieces of code is data, or the data types you use in programming. So we're talking about data types. We're talking about classifications of the data that you would use in a program, and the data type determines what can be done with that data. So for example, we're talking about, also we assign variables. So the variables have a symbolic name, and then those are assigned data to that name. So for example, you say variable 10 would equal 10, and then if you were to write up that variable 10 in anywhere in your program, it will have a value of 10 in the program. So,
what's the difference between data and variables?
So data is,
Data is what you store in variables. Like it's the information that you store in a variable. A variable is just a container for a type of data. Or like
so like the example, you could say that like variable x would equal 10, and then 10 would be the data that's stored in the symbolic value of x.
And then
so it's some representation of the data.
Yes. So we're going to go over the types of data, and first one will be numbers, and those are actually split into two types, integers and floats, and those are pretty simple. Those are basically whole numbers, or numbers without decimal points become integers, and numbers with decimal points become floats. So 42 is an integer and 4.2 is a float. Strings, so they're a sequence of characters, and they can both be letters and numbers, and within a program they'll be surrounded by brackets, or not brackets, they'll be on quotation marks. Sorry. So the example would be like quotation marks around the word test, or quotation marks around the numbers, and those will be stored as strings. And when you store those numbers, you can't do math with the numbers. So like when you have, going back to numbers, you can do math with these. But if you were to use a string and have 1, 2, 3, 4, you can't actually do math with it. It's treated as like a word. So next really important one is Booleans. They boil down to just true and false. Yeah, that's it. But you can do a lot of important things with Booleans, and they make up a lot of how you control what your program does. So you have Boolean operations. So you have three operations, AND, OR, and NOT. So AND, so let's say that italic A and B are separate Booleans, and A and B is only going to be true if A and B are both true. If one of them is false, the entire statement is false, and if both of them are false, the entire statement is going to be false. Or on the other hand, is if A or B is, or either of those is true, then the entire statement is true. If both of them are false, then it is false. And then not just reverse the Boolean, so if not true is false. So.
Or you mean opposite of A?
Or, yeah, so if you were to say A is, or A would be true, and then you say not A, it would be false.
Yeah.
So, and here's another thing. So, comparisons, they all boil down to Booleans. So if you were to compare two things, so let's say data to comparing two numbers, if like 6 times 7 is equal to 7 times 6, that would be true. So it would boil down to a Boolean. And we have a couple ways to compare values. So equals and not equals. So I guess if a value is equal to another and if a value is not equal to another, it will become true or false, depending on how you want it. And then less than or less than equal to. So if you have numbers, you can compare them to be less than or less than equal to. And if you want to compare numbers to be greater, then you can compare those. But if you use those, they will always return a Boolean. So you have to watch out for that. And the reason Booleans are also really important is because they fit into conditionals, and that's how you actually control the flow of your program. So going through your program is kind of like a decision tree. So starting from the top, it's going to go down, and then depending on what comes through, it's going to choose decisions, and it's going to control how your program flows. So the first type of conditional is an if. So if you see if, and then you put a Boolean or a conditional statement. So let's say, yeah, if power level is over 9,000, so it's going to attribute that to either true or false. And if it is true, then it's going to output this text within the program. And then in this case, since, well, moving on to the next one, it's an if-else statement. If you just put if, it will only execute if it's true, but the else comes in if the consequence is false. So if true, it's going to do the first part within the if statement. If it's false, it will do what's in the else statement. And then while loops are for more like looping over multiple times. So while the statement is true, it will continue to go through that state, or it will continue to go through the loop. So the example here is when I equals 0, then while I is less than 10, it will add, well, this I++ means that's going to add 1 to I each time it loops through. So each time it reaches that point, it's going to add 1 to the value of I. So that means it's going to iterate through the program 10 times. And then here's another one, a for loop. It's another type of loop, basically, except for you can actually give it the conditions within the, or basically you just give it the conditions within its own initialization. So you're going to say, you're going to give it its initial condition, you're going to give it the Boolean operation, which says until how long it should run, and then you're also going to give the changing condition for it. So if you look at the example, you're initializing I equals 0, so instead of putting I equals 0 outside of it, I equals 0 is right here, and you have the condition of when it will stop, and then the change. So for loops are a little bit more contained in that way, and it's also a little bit cleaner when you write for loops.
So what does the program get to do? It's going to
execute this code 5 times. Whatever's inside it will execute 5 times. So now when it comes to storing more data, if you run out of, I guess if you say you run out of variables, or you want to be able to hold a bunch of things, so let's say you have a bunch of points, you can initialize an array, which is basically a table of values. So let's say, let's say you wanted to keep a lot of dots together. You can make it a dot array, and then you can keep all the points in that array, and then you can start, you can call each index. So if you want the first one, you actually have to call the 0th index. So because the indices start counting from 0. And then you can count up to however, or whichever point you want, and then you can call that, and then that's an easy way to store your data. So here's a little bit, here's where it kind of ties all together. So this goes into functions, and functions basically are blocks of your code that are designed to do specific tasks. So we have a function example here, and the function, you have the name, we'll basically call it function, and then the name of the function, and then the parameters that are input into the function, and then the code goes in between. So return would output this specific number. So what this function does would be it takes in 2 input values and then returns returns their product. Couldn't think of it. Sorry. And then objects are a kind of, or basically it's just data with customizable properties. So instead of saying that they have to be strings, integers, booleans, you can say, well, let's give this object a bunch of different types of those. So right here we have an object called person, and we gave person a name and age. And then if you want to call any of those specific things, you can say person dot, and then the whatever you gave it. So, and that's basically like an overview of all the things you really need to start building your programs. Programs, like, yes.
Awesome.
Yeah. Okay.
Alright, now we're going to do the fun part. Before we move on, I want to note that anybody who's programmed in like another language is going to have an interesting time. JavaScript is a very loosely typed language, which means that you don't have to like say exactly what you're storing in variables before you create them. As you can see in this example, you create a variable by calling it var, and then whatever you're going to call it, and then whatever is going to go into that variable. So in this example, I could have just done var person equals 21, and it doesn't matter. Whereas if you're using something more like Java, which is really strictly typed, you would have to say like integer, age equals 21, and you couldn't just like change whatever type of data you store in it. And objects can have whatever type of data. Again, in Java, or in JavaScript, in Java, like you can't mix types. It's really complicated and difficult to use.
It's between Java and JavaScript.
Yeah, JavaScript is loosely typed.
Or no, I mean like the difference between because they sound alike.
Yeah.
Wait, so Java is like a programming language created by Oracle, and it's used mainly for like large-scale projects, while JavaScript was kind of, so they basically named it to try and ride the wave of Java, but it kind of just got a lot of people confused. But it's mainly a web development language, so they're separate.
Okay. And JavaScript is what's used in websites normally, so that's why we're going to learn it. We're going to use this tool called Bonsai.js, and it's a library for creating graphics with JavaScript. So, yeah, it has a cool website. Alright, so we're going to step through a couple of really simple examples of how Bonsai.js works, and then we're going to create our own thing. The example we created was Pac-Man. Like just the Pac-Man game, and you guys can either do that or do your own thing. But I'm going to give you some of the tools that you need to create some of these programs. So whenever we break out our computers, you're going to want to go to orbit.bonsai.js.org, and that's like their compiler for their own Bonsai.js extension. All right. So starting at the very top here they create a variable, and they call it arect1. And in that variable, they store a rectangle object. Each rectangle has 4 properties attached to it. This first 0 is the x-coordinate that the first rectangle is drawn at. So, yeah. So when you start off this example, all of these rectangles start on this side and they move over. And the 0 coordinate is up in the top left corner up here. So as you can see, this first the red rectangle, it starts at 0, 0, so it starts up here in this top corner. And then it is 150 by 150 pixels in each direction. So it actually turns out being a square. You fill it with the color red, and you add it to the stage. And the stage is just the Bonsai.js version of their canvas of the thing that you're drawing objects on. So this is how you make a very simple object with Bonsai.js and JavaScript. And again, they do this for 2 different rectangles. This one starts, the x-coordinate is 0 again, so it starts on this side. The y-coordinate is 200, so it starts down 200 pixels. Actually, normally when you're dealing with websites, the origin, so 0, 0, is up in the top left corner, which is not really what you're used to if you do like mathematical graphs, Cartesian plane. And going down is positive y direction, and going to the right is positive x direction. So here it starts at 200 down, which is right about here. And this one starts at 400 down, which is right about here. And then it does, so they actually break it up into 3 different ways to animate it. The first one is the simplest. Each rectangle object has an animate function. You call it for 1 second, and it moves in the x direction 150 pixels. So let's say we want to make this much slower and run it. We can just change it like that. Or we want to make it go further than all the others. So in that 1 second, it needs to go whatever this length is. So as you can see, it goes faster than the others because it needs to go that whole distance in 1 second. It needs to go twice the distance in the exact same amount of time. And again, we can play with the others and make them move at different speeds. So this way of calling animation, it actually creates an animation object, which is kind of a weird way to think about it. You can see the animation declaration, which is very similar to this. It gives you the number of seconds and then the distance it's supposed to go. And then the rectangle, you call the animation function, and you just, very similar to this, it just puts this in the animation function of the rectangle. And then this one's also similar, except you call an animation function, and you add a subject, which is this third rectangle, and tell it to play. Again, these are like details that you can look up if you need them, but this is vaguely how it works. Does everybody follow along with that so far? You understand basically how this program works. If anybody's lost, feel free to ask questions now before I move on. Yeah.
What would be the syntax if you wanted it to move in the y and x direction? So like, how do you do combinations?
Right. So in JavaScript, objects are denoted with brackets. So let's say we want to move, let's take this one. So you're passing to it an object that says move in the x direction this many pixels. So we could just add something that tells it to also move in the y direction. And it does that. In this case, it moves up. If we want to go down. No, okay. Oh, okay. So the pixel is actually like the exact pixel that it's moving to, right? So if we wanted to move down, we could actually do that. Further down. Okay, there we go. Now it's moving down. Yeah. Does that make sense? Any other questions? Yeah.
How does a node do that? Is it something like within Bonsai itself, or
right. So Bonsai.js is just a really long JavaScript file that tells it, like, if you pass in this information to this variable, do this. And the great thing about this is it just abstracts all of that for you, so you can do something that's really readable instead of you like going in there and having to say like move this object this many pixels. It would be much more code for you. So Bonsai helps with that. There are plenty of these types of things. I actually looked up today and found 30 very quickly, like visual JavaScript files that do that kind of thing, that make it a lot easier to like draw charts in JavaScript. Other questions?
So what is sort of the, when you described it in the third way with the function, how does it know which function to play? Sort of how do you define that?
Right, so somewhere in the Bonsai file, it has this like animation object, and each animation object has like a subject that is being animated. So here you're just adding the rectangle to that, and each subject in the animation object can be like turned on or off. So like this is a method that they wrote, and like again in theory you could tell it like manually to move this many pixels, and it would do the same thing as dot play. Does that make sense?
But I guess my question is, where in that line do you put in the function value of where it's going to move? It's just the line above, or can you tell it to execute a different function?
Right.
The same object?
Right. So yeah.
Or can you say define the animation as an object and then come back to it later and say, you know, now play that animation that you saw like 10 lines before.
Right.
Like animation 1 versus animation 2 or animation 3.
Let's do it. Yeah. So here we can tell it to either play the same animation that was called above, or to play the animation that I just made.
Okay.
Does that make sense?
Yeah.
Any other questions? Cool.
Is there an advantage to one way or the other? At our basic level, it shouldn't be.
No. Yeah, it depends. It depends what you want to do. Like again, in this case, this one is like the simplest to write, so I would just do this. But if you want to do something more complicated, or like here, if you want to use the same animation again later, you could create the animation object and just apply it to multiple rectangles. So this has like tons of examples of really cool things. This is one of my favorites. So like these are just all the possibilities that you can do with this with Bonsai. So here you can like click JavaScript, and this goes up and adds more people. Same here, CSS. It's pretty fun. I highly recommend just playing around with this and seeing what it can do. This one makes lots of circles. Again, these programs are longer, and if you want to really understand how they work, you're welcome to. I'm not going to make you do that right now, though. Yeah, but you could do a lot of cool things with this. I want to show you one more quick thing that might be useful if you're doing backend. So this is an event listener. So somewhere in this Bonsai code, it says, like, whenever you click, listen for this event, like listen to the keyboard and listen to the mouse. And if somebody actually clicks, then change the color. Right? So again, this is abstracted for you. What is it? Yeah, and that's what this method does. So for each object, it has an on method. So if you do a variety of different actions, you can click, you can do a key event, so click like A or click B on your keyboard. And somewhere in the documentation it'll explain what you do in all of those cases. Then it calls this function, which takes some data. Okay, so let's start back up here. So here's where it creates the Bonsai rectangle object. And this is just a different way of doing what we did before. You could actually just call this new rect, and it'll make the exact same thing and do the same thing. But they decided to call it that. Again, it creates a rectangle at this x coordinate and this y coordinate. And again, normally these are the top, this is the top left corner of the object you're creating. And it adds this attribute, fill color, with red at the very start. And this is the array that we talked about. So this actually has 4 spots. This array has 4 spots in it. At the 0 index, it's storing the word green. At the 1 index, it's storing blue. At the 2 index, yellow. And the 3 index, red. Here you create an index variable and set it to 0. And then you add child to stage, which again just means that you're putting the object you created on the actual canvas so you can see it. And here, okay, so in this line, you're doing this thing, which looks kind of complicated, but a little similar to what we did before. So this is called incrementing, when you have like 2 pluses, and if you have 2 minuses next to each other, that's called decrementing. Normally you'll see like index plus plus, so you'll see the addition after, and that just adds 1 to whatever variable you have. In this case, they did the plus plus before, and all that means is it wants you to add 1 before you do anything with the statement. So if we did plus plus after, it would evaluate the statement, and it would see that index is 0, and then work from there. But in this case, it adds 1 and then evaluates the statement as if index is 1. Does that much make sense? Anybody lost?
What is the evaluation involved in this case?
Evaluation evaluates this entire conditional, where you have this equivalence. So it says take whatever is on the left and see if it is the exact same thing as whatever is on the right. So here, colors.length is going to be 4, because we put 4 things in this array called colors. And then it checks the index. And in theory, the index should never be 4, because you only have 4 elements, and it starts at 0. So your index should be 0, 1, 2, or 3. So it says if your index ever hits 4, you should actually reset it to 0. And that way, it's only calling colors that are actually contained in this array. Does that make sense?
No.
No. Okay. Let's see. So you understand this part, right?
Yep.
If it's 4. Okay. So when you see this statement, you start off where index is 0, right? This increment adds 1 to that before you even do anything. So now this evaluates to 1. And then it checks, is 1 equal to 4? And it says no, so it doesn't do this. It just skips it. You can put brackets here. That's kind of your prerogative. I normally don't, but it makes it a little cleaner. Yeah, so just do whatever's in that statement if this evaluates to true. So eventually, your index will evaluate to 4, right, if you just keep adding to it. And then it'll say 4 is equal to this, which is also 4, and it'll actually do this and reset index to 0. Right? So that down here, when it actually calls this index, it should never call something more than 3. Does that make sense?
Yes, but what is it going to do when it finds that the statement is not true?
The statement should generally not be true. It's only going to be true when index is 4.
So how does it know to change color when it's not true?
That's what this line's for. So, and this line's evaluated no matter what. But again, like there should be no case in which index is equal to 4. Because if you add 1 to it when it's 3, and you see that, and you immediately reset it to 0, so nothing happens. And when, so whenever this statement is executed, whether it's true or false, it'll come down here, and it'll set the attribute fill color to whatever color is at that spot in the index.
So line 16 is basically a loop that makes sure that you never get out of the
Right.
0.
So, 0 is green, 1 is blue, 2 is yellow, 3 is red, and then it starts over green, blue, yellow, red. Okay. Does this part make sense to everybody?
And where was the listening part again? The listening part.
It's right here. This. It's just listening to see if you click. Any questions? That was a good time to ask about this. Yeah.
Where's the part where it adds 1 to the, like goes to the next
Index?
Yeah.
Yeah, that's the magic that happens right here with this really confusing looking thing. So it Whenever you see a plus plus like that, it's adding to the variable. So usually it's called after. And in this case, it would just add 1 after the statement's evaluated. But if you put the plus plus before, it'll add 1 before it's even called.
What if you just wanted it to change color if you click exactly on the rectangle area, not elsewhere?
It does that. See, you can click anywhere. That's why it calls the that's why it calls the actual object here. I'm not totally sure this will work, but in theory, if you call canvas or like whatever it calls it, stage. No, but there should be some way to do it. I just don't know what it is. If you click anywhere, it'll change. Yeah.
Okay, so the list of colors, are they strings or are they extra colors?
Right, they're strings. So in JavaScript, strings can be called with either like double quotes or single quotes, and it really doesn't matter which, as long as like you don't start and end with different things.
So then there's some background running telling that this string means this, you know,
Right.
wavelength.
Right. So it says like if you take this word green, then convert it to like this color value and output that.
Will there be any difference in function functionality if it's index plus plus?
Yeah, let's see. Yes, so.
You have red twice.
Yeah, it ends up calling red twice because again, it adds 1 to index afterwards. So like this will evaluate to 3 in some case. Like this part will evaluate to 3, and it'll say, or this part will evaluate to, this part will evaluate to 3 when it's red, or when you're turning it red, and it'll think that's cool. And then immediately after it looks at the statement, it'll add 1 to it. And then you'll go here, and it'll call this, but this will actually, index will actually be 4 at this point, and 4 isn't a valid index because you only have indices that are from like 0 to 1 minus the length. And because it doesn't know what to do, it'll just like keep it whatever it was before. Like, normally your code would just like break at this point, but this is why like Bonsai is nice and JavaScript's nice because it won't actually like completely fail on you. But yeah, it shouldn't work. That's why like red stays twice even. Like you click twice and it stays red. Does that make sense? Kind of. Okay. Anybody else have questions? Okay. All right. So now is going to be like the workshop part of the class where you guys are going to make Pac-Man. So they actually have a Pac-Man object somewhere in here.
Research.
And it looks kind of funny, and then B, it just kind of moves across the screen really slowly. So I'm going to walk you guys through kind of what each of these parts is and what it does, and then it's your task to create the little circles and make it responsive so that it's like the one that I wrote. And you can also like change it so it doesn't look so funky. Okay, ready to go? Again, if you guys want to follow along with this, it's orbit.bonsai.js.org. And you just search for Pac-Man from here. Okay, so we start off by making an eye object, which is this little white circle here. Because you don't like, or it starts off at this value, which is like kind of off screen actually, which is why you don't see it initially. It's actually like right there. So the y coordinate starts about here-ish, and the x is about here. So it starts like a little off and actually up, because normally positive y goes down. And 7 is just the size, so we could make this big, and it would make the I bigger. That's pretty creepy, I don't want to like that. Okay. Okay.
Is it white or is it transparent?
It's white.
Oh,
So-
is there a transparent in?
I don't know. I haven't tried. You can look it up though. We could make it red if we wanted to though. And then it would be non-existent. So this is attribute fill color. So again, this is what fills the inside of our circle. I don't know if I really went into this the last time, but this notation is called hexadecimal, and it allows you to access. It essentially creates values between 1 and 16, but because you can't do that in one character, it goes into letters, and it goes like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 becomes A, 11 is B, and then etc. So we can change this. Fab, and it creates a different color that's a combination of things. So the first character represents the amount of red. The next one is green, I think, and the last one is blue. So you can change like the amounts of each. If I start with 0, then the last one is blue. I can make it green, or I can go back and make it red, which will be invisible. But it starts off like that, and if you have every color, it becomes white. If you have no color, it should be black. Okay. Alright, this part's kind of complicated, and I don't really want to get into it right now, but in general, what this does is give the two different,
I was wondering, how are the 6-digit hexadecimal codes? You know what I'm talking about, the old, maybe that's an older style.
yeah, you could do that too.
Does it
Same
work
thing.
the same way?
It's just like more specific. So it's just like if you have like a tens place and a ones place.
Like red 1, red 2.
So like if you only wanted to call things between like 1 and 9 or like 0 and 9, you were fine with that. But if you wanted to call things between like 0 and 99, it gives you more like gradations. You can call it more specific colors. So again, this you should be able to see that. Okay. Great. So here again, the middle part just represents green. The 2 on the left represent red, and the 2 all the way on the right represent blue. So I just turned on the green ones, and it made the eye green. Right.
So it doesn't matter whether it's 3 or 6?
Yeah. Again, you can use more. This allows you for more like gradation. You can put just like slight amounts of whatever color you want.
And what's the range? It's between 0 and F, and what's in between? 1 to 9?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F.
And that's called hexadecimal.
It's used a lot in computer science. Okay, so these two represent the like on and off state. Let's actually see. I'm not going to get into really what this does yet, but so if we leave it on the on state, it has a mount and it's open. And if we leave it on the off state, it just doesn't have a mouth. So we'll get down here and I'll explain exactly what this line does. But it pretty much just switches it between having like an open mouth and not having a mouth. It's a little creepy. It's actually, okay, that's really disconcerting. Get rid of that. Okay. I'm not sure if that's better, but alright. So again, this is really complicated. I don't want to get into exactly what each of these like letters and numbers mean. But the important part is at the end. So essentially, this tells it, let's see, off, just the one with the mouth. what it's kind of doing is like creating lines that like cut off where you can actually see, and that's kind of what all of this is. But we won't really be editing that, so I'm not going to go into it. You really just need to know that there are two different states, and it switches between the two. This creates the Pacman object. So again, it like by default creates a circle. So you could also just say like new circle, and it'll create this. Okay.
What other shapes are available?
Rectangles, triangles. So if you go to the Bonzo website, they have documentation, and you can look up a lot of these things. Like what are the different classes they have? So there's circle, ellipse, groups which we'll get into, polygons, points, rectangles, stars. So those are the different types. Alrighty, so any questions? Alright, this creates a group. So a group is exactly what you would think. It's just like a group of objects, and it lets you refer to them all together. So here the group it's creating is just like the Pacman itself, and then the eye we made. Okay, so it's saying, start this at the y value that's 100, and rotation, or let's always change this. So now we can start it up higher if we want. And it, again, as you notice, it moves the entire thing. It moves the eye and like the red part, the Pacman part. And rotation allows you to rotate it. So if you turn it,
radians?
I think so. Let's see. Oh. Yeah. Yeah, so pi is rotating it all the way around. So we're going to set it to this, which I think is a little closer. And I'm also going to move the eye up a little, because now it just looks weird. All right, cool. So we have a little bit more normal looking Pacman. Here it adds this group to the stage, so it puts it all up there. And this kind of does the same thing. It says, in this group called Pacman, we want to put these two objects, the like Pacman itself, and then the eye object, and refer to those all together from now on. Here, we're creating an index of 1, and we're creating a loop. So, this is essentially the timer, so we can set it to a different time, and it'll move faster or slower. Make it move really slow. Oh, that's way too slow for me. Move fast.
How do you change how fast it moves its mouth versus scrolling across?
So right now it kind of does both together, which is the issue. Again, you can like look into it and like work out the details of that, but that's abstracted with the code that they provided. Right now it just kind of does all of the movement in one Swift. Like it treats it as one and moves it together. Actually, we could change that. Okay, so let's do a 10. So this line. This looks really confusing, but it's really just a conditional, and like an if-else statement. So it says this is called a modulus operator, the percent sign, and it means divide this first thing by whatever the second thing is, and figure out what the remainder is. So in this case, it's saying divide I by 2, and if the remainder is 0, choose on, and if the remainder is 1, choose off. Let's see what happens when we change it. You can see that it's not moving as regularly as it was before. We can do it a little slower. Let's see. So it's only in the off state, like really quickly, and it's in the on state. Right, so this is saying that whenever I is divisible by 4, you should switch it to the off state, but otherwise it should be on the on state. So I increments, as you can see down here, each time you add one to it. So for each iteration, you'll start off with like I is 0, and then it'll go to I is 1. Is 1 divisible by 4? No, so leave it on the on state. Is 2 divisible by 4? No, leave it on the on state. Is 3 divisible by 4? No, leave it on the on state. Is 4 divisible by 4? Yes, turn to the off state. So 3 out of 4 times, it'll be in the on state, which is why it looks like it's keeping its mouth open longer than it was before. We could make it even worse if we wanted to. And just every so often it would close its mouth. Okay.
Could you also reverse off and on, and that would be the opposite? Right?
Yep. Great. And then all this does is tell you where in space it is. So it says set the x component to I, which is, again, that thing that we're iterating. So it starts off at 0, because I is 0. And then the next time, you'll increment. So it'll set x to 1, and then x to 2, x to 3, and that's how you see it move across the screen, because it's moving in the x direction, because you're incrementing this.
So in theory, you could make another variable I. Can you call it something different than I, like j? And then you can just treat these completely separately, right? Because you can change the increment at which you add them or something like that.
Yep. Yeah, and you can play around with that.
So that they don't have to be, because like right now, they're still related. You're just changing the relationship by the modulator. Right?
Okay. So at this point, I'm leaving it open to you guys to make your Pac-Man. At a high level, what you have to do is create little objects that are circles. Yeah, do you want to say something?
On line 14,
yeah.
What are the question mark and the colon mean?
Right, so this is just like the exact syntax for this weird kind of like if-else statement. So this is the conditional that you have to evaluate, and then it has the question mark. And then it has, if it's false, do this, and if it's true, do this. So if it's false, put it in the on state. If it's true, put it in the off state. And the colon is what separates those two.
So does question mark mean false?
A question mark just separates like the conditional from the if-else. Yeah. Any other questions?
What did you say was the source to look for shapes and stuff like that?
It's in the documentation. So docs.bonsai.js.org. But in theory, you just have to create, a few new circles and position them in the right places. Then you have to make them disappear, which you can look through here. Look up something like remove, and you can see how you remove objects. It's this remove child function. So all you have to do is create these little circles, remove them when their x component is equal to the x component of where Pac-Man is. And then you'll have your own Pac-Man. And if you have time, you can make it so you can click on it and turn it on and off. Or you can create your own game, but that's the one I know how to do, so I'd be most helpful with that. Anybody have questions before I let you go? Okay, so go ahead and try and make Pac-Man, and we'll walk around and try to help you out. Just raise your hand if you have a question.